All right, this video goes over lesson 5. Sequences are functions. These dots right here would represent like bowling pins. That's why it's called bowling for triangles. So we have step 1, step 2, step 3, step 4, and now we're going to do step 5. So step 5 would have all of the dots from the previous one. So it's the 10 dots here, but then new dots are being added. So the new dots that are being added, the new dots that are being added, I'll make these be a different color, boom, 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 boom. So there's 5 additional dots. Well, the story of this is the fact that the step number matches the amount of new dots that are being added. So step 4, see 4 new dots are being added. Step 3, 3 new dots are being added. Step 2, 2 new dots are being added. So the step number matches the number of new dots to make the triangle. So step 6 is going to add 6 new dots to what we had previously. So when you're talking about adding on to the previous thing, that's looking at a sequence recursively. So that's what the lesson is recursively looking at a sequence. All right. So the first question here is what makes sense for n? Well, n can't be decimals or fractions or anything like that or negative numbers. So n has to be greater than or equal to 1. And n is a whole number. So no decimals, no fractions. All right, because you can't have step 4.5 or step 4.1 or step 4 3/4, right? That won't work. You go across like you're jumping across stones across a creek. You go to step 1 and then step 2 and then step 3 and then step 4 and then step 5, right? So you're landing on the different rocks here as you go across the creek, right? And you're jumping between the rocks, right? And if you have decimals, you'd be landing in the water. So we don't want to do that. Complete the table here. So the D1, D2, that's representing what happened before, the previous step. So D of 3 is what happened before, and that's 6, plus n, the new number that's being added, the step number. So that's how we get 10. And then the next one would be D4, which is 10, the last step amount, and then plus the step number 5 would give us 15. So there's 15 in the new thing. So the equation for that's what's important here, is the fact that your total number of dots, D of n, is the total number of dots. And it says that up here. D of n is a function, or the number of dots is D of n, right? So D of n is the number of dots, and then the step number is n. So those are how it's defined. So D of n is equal to the step before, which would be D of n minus 1. Notice it's 1 smaller than the 4 and 1 smaller than the 3, etc. up here. And then plus the step number n. All right. So consider the triangle sequence here in the problem. And is it algebraic or geometric, or not algebraic, but arithmetic or geometric, or what is it? So the first number is 1, and then followed by 3, and then by 6, and then by 10, and then by 15, comma, and then you just keep going, right? Well, I'm not multiplying by the same thing or adding the same thing every time. It is neither. And the reason why I know is because I'm adding 2, I'm adding 3, I'm adding 4. That's not adding the same amount, because arithmetic means you're adding the same number over and over again. Geometric means you're multiplying by the same number over and over again, and that's not happening. So can you write this as a formula instead of this formula here is the recursive formula, because it's relying upon the previous term, which is what this is. This is the previous term. and then n is the step number being added to it. Well, there's another way to write it. You can jump anywhere you want to, and the equation for it would be d of n is equal to the step number times 1 bigger than the step number divided by 2. And that would allow us to jump anywhere we want to. So here's how this formula works. So this would be 4, right? So we got the first term, second term, third term. That's 4. So n is 4 right here. If we put 4 into the equation, we would get, that would be d of 4. So we get 4 times, and then you put a 4 in there, you get 5, is 1 bigger, which is 20, divided by 2, that would equal 10. So that's where the 10 is coming from, using this equation. So this would be what's called the explicit formula. But mostly this is relying upon the recursive formula. Okay, so we're going to write all these out with the recursive formulas. So basically, I'm going to use function notation for this. So f of n minus 1 means the previous term. All right, and n is whatever term you are. So that's your term number. Oops. Erase a little bit here. It's the term number. And then f of n would be the actual, the current term that you're on. Okay? So we're going to look at this and we're going to say, what's going on, and what's going on with this one? Well, it's adding 10 every time to the previous term. So we're going to do f of n as you take your previous term and you just add 10 to it. So it's the previous term plus 10, previous term plus 10, previous term plus 10, previous term plus 10. And it just keeps getting 10 bigger each time. And of course, that's arithmetic. The next one is multiplying by a half. So you're getting smaller, right, by a half each time. So that's geometric. So that's f of n, that's your current term, is equal to your previous term, n minus 1, times a half. So I should have squeezed that in the front here. So I'm going to get out the eraser here. I'll squeeze that in the front. So it's going to be 1/2 times f of n minus 1. The next one's doubling each time, so that's also geometric. So it's going to be f of n is equal to 2 times f of n minus 1. And that's doubling each time. And all of these, n is greater than or equal to 2. That applies to all of them because the first term, n is 1, is there. Okay, now we're multiplying by half. So this is also geometric because it's doubling the bottom of the fraction, doubling the denominator. So that's going to be that. So it's f of n is equal to 1/2 f of n minus 1. And that's the same. It's the same answer as number 2. And then the last one is not. Oh no! Well, I skipped one here. Okay, so this one here is arithmetic because we are subtracting the same amount, which means we're adding the same negative amount. So f of n is equal to the previous term plus -7. Okay. The next one is neither arithmetic or geometric. So what's going on with this one here is we are doubling the 3, and then you add 1, you get 7. You double the 7, and then you get the 15. So we're doubling the previous term. F of n is equal to 2 times f of n minus 1. So we're doubling the previous term, and then plus 1. Now that extra plus 1 there makes it neither, because it's doing two things. It's multiplying by 2 and adding 1, which means it's not going to be the same thing every time change. So that makes it not be arithmetic or geometric. All right, now we're going on to this page here. So this the summary through, you want to read through here, and you want to absorb what this is saying. So basically, here's the main highlights of this. So there's a sequence, and we're describing it this way, and because it's 4 more than the previous term. And the important thing here is you have to always say what the first term is. So the first term is 6, and then we know to add 4 more, and add 4 more, and add 4 more, and add 4 more. We can make the first term something else, like it says right there. You can make it 81, or you can make the first term anything. But the rule is the previous term, right there, previous term plus 4, previous term plus 4. And then down here, it talks about, let's see, combining this information gives the recursive formula. Okay, and then the n greater than 2 just means that we've had to define the first term. We keep going from there. We conclude that n greater than 2 at the end, since the value of f at 1 is already given, and the other terms in the sequence are generated by inputting integers larger than 1 into the definition. All right, so that's that. Now, here's the 2 pages that you're supposed to do. There's this page here. This is matching. So you're going to match, like, this one matches to this one, or this one matches to that one, or this one, you're matching the explanation of the recursive. So over here, these are the recursive ways, and then that's the sequence. You got to match those together. A lot of people had trouble with D, so I'm just going to go over D with you right now. So we're going to generate the terms here. So here we go. This is how I kind of explained it, and it seemed to help in class today. So we have 1, 2, 3, 4, 5 terms. Okay, n is 1, means n is the first term, or first step, second step, third step, fourth step, fifth step, and that's n. N is 1, n is 2, n is 3, n is 4, n is 5. Okay, so it says D of 1 is 1. So the first answer is just 1. So it's 1. Then it says previous term, that's what that means right there, previous term. So I'll call it the PT, the previous term, times the step number. Okay, so here we go. Previous term is 1 times the step number is 2. So the answer would be 2. The previous term is 2 times the step number is 3. So it would be 6. The previous term is 6 times the step number is 24. The previous term is 24 times the step number is 120. So you're doing this. I'll go yellow, I'll do orange. So you're taking the previous term times the step number, and you get down here, then you go up to there, answer 2. Previous term times the step number 6, put the answer there. 6 times the 4, 24. 24 times the 5, 120. And you just keep going like that to infinity, like Buzz Lightyear, to infinity and beyond. All right, hopefully this helps.